Vincent the Bug draws all the diagonals of a regular hexagon with area 720, splitting it into many pieces. Compute the area of the smallest piece. To solve this problem, the first step is to identify which part is the smallest piece. Using our eyeball, it's not difficult to find that this part, let's say triangle AGI, will be the smallest piece, same as this part. So we have, I think, 6 times 2, 12 congruent small triangles. Okay, those are the smallest piece. Next, how can we find the area of this one? As we can see that we can write down here, the area of the triangle AGI is half of the area of triangle AGH because this AI is the perpendicular bisector of GH by the symmetrical property of the regular hexagons. And then we want to find this area of AGH by looking at the bigger version, which is area of AEC. Let's see, triangle AEC, I will say it's half of the total area of the regular hexagon. You may ask why. Let's take a look. Now let's use the purple color here. Here, let's say this is angle O, the center. Okay, the parallelogram, or actually this is a diamond, or some people say rhombus. Okay, ABCO, because these sides are all congruent. Okay, and they are parallel to each other. So this is a rhombus. The diagonal of the rhombus bisect the rhombus into two equal parts. Let's say diagonal AC cut this rhombus ABCO into two congruent parts, triangle ABC and triangle AOC, which means this part, the purple part, is half of the area of this rhombus. Similarly, this triangle EOC is half, and triangle AOE is another half. And adding together, we know that the red region, triangle AEC, the area will be half of the entire area of this regular hexagon. So this is the first step. We are done. Next, let's find the relationship between, I will use hot pink color, triangle AGH to triangle AEC. Okay, we know that GH parallel to EC, again by the property of the regular hexagon, you see these two diagonals should be parallel to each other. Then we can know triangle, you can say triangle AGH, similar to triangle AEC, with a scale factor. So you know that the scale factor is 1/3. How can we know that? We see on triangle AGH, BH, whatever here, and all these tiny 6 triangles, they are congruent. Okay, and we know this will be an equilateral triangle because in this big one, all the 3 diagonals are congruent, and the angle GAH will be 16 degrees, which means these 3 sides, they are congruent. Okay, and we know BH is congruent to AH. Similarly, FG is congruent to AG, which means all these 5 side lengths are equal. Then we say we know that GH is 1/3 of the length of FB, and FB is equivalent to EC in length. In this way, the corresponding side has a ratio of 1:3. The scale factor is 1:3. Then by similarity, we know that if the length is in the ratio of 1 over 3, then the area will be in the ratio of 1 over 9 because it's the scale factor squared, okay? Then we can go back so you know that triangle, so S triangle AGH will be 1/9 of the whole area of triangle AEC. AEC we already know it's 360. So this will be 40. Now you plug this value back into our equation here. So half of 40 will give you 20 as your final answer. Okay, let's review everything from the very beginning. Step 1. Identify which part is the smallest piece. Step 2. You find that this tiny piece will be half of the area of the triangle AGH. And then you find AGH is 1/9 of the area of AEC. And AEC is half of the total area of the hexagon. So step by step, finally you get area of AGI will be 20. Is this one clear? Thank you for watching. See you next time.